Hello friends, welcome back to IQ Nest. In today's video, we would be discussing about the basic and fundamental concepts in chemistry as part 2. So in this video, we will be focusing on the basic concepts in periodic table. So in our previous video, that is in part 1, we already discussed about atom models and various particles in atom. So if you haven't watched that video, please do watch, and if you like it, please subscribe our channel and support us. So friends, without further delay, let's start with today's topic, basic and fundamental concepts of periodic table, that is chemistry part 2. The first point is Lavoisier classified elements into metals and non-metals. Lavoisier also established methods for measuring and weighing in chemistry. Periodic table was discovered by Dmitry Ivanovich Mendeleev. The father of periodic table is Mendeleev. So Mendeleev discovered the periodic table for the first time, and that is why he is known as the father of periodic table. Periodic laws were put forward by Mendeleev. Mendeleev's periodic table was based on increasing order of atomic mass, and according to Mendeleev's periodic law, the physical and chemical properties of elements are periodic functions of their atomic weights. But modern periodic table was discovered by Henry Moseley. So Henry Moseley is known as the father of modern periodic table. Modern periodic laws were put forward by Henry Moseley. The next point is Dobereiner classified elements on the basis of atomic volumes. The next topic is Dobereiner's triad. So you can see the picture which depicts the triad and also the calculation for the triad. So we'll see in detail what is the triads and what is the importance of the triads. The first point is Dobereiner's triads was one of the first attempts towards the classification of elements. Dobereiner arranged similar elements in groups of 3 elements called triad, such that the atomic mass of middle elements of the triad was approximately the arithmetic mean of other 2. However, this classification was not feasible as all then known elements did not follow this rule. The law of triads was rejected as some of triads nearly had same atomic masses, example iron, cobalt and nickel. So in this picture you can see that there are 3 elements, lithium, sodium and potassium, and if you add the atomic masses of lithium and potassium and divided it by 2, you will get the atomic mass of sodium. So that is the concept behind Dobereiner's triad. And this law was rejected because some of the elements like Fe, cobalt, nickel does not follow this rule. And the next topic is Newlands rule of octaves. The first point is the law of octaves was put forward by John Newlands, hence it is known as Newlands rule of octaves. Newlands arranged elements in the order of increasing atomic weights. It was noticed that every succeeding 8 element repeated the properties of the first element, just like the 8th note as in the octaves of music, that is sa, re, ga, ma, pa, da, ni. Example, Na, that is sodium element, resembles in their properties with Li, that is lithium. Similarly, potassium with Na and so on. So you can see that if you take Li, that is lithium, and if you count the 8th element, it will be sodium, and both lithium and sodium show same properties. So that is the Newlands rule of octaves. And the next point is law of octave worked quite well for lighter elements but failed with heavier elements. It could not be extended to elements with atomic mass more than 40. No place was left for unknown elements, and so many elements occupied wrong positions. This resulted in the rejection of the attempt. So that is the details about Newlands rule of octaves. Next is atomic volume curve. So you can see the picture of atomic volume curve, and we'll see what is atomic volume curve. So the first point is atomic volume curve was put forward by Lothar Meyer. As per this curve, it was noticed that when atomic mass was plotted as ordinates and atomic volumes as abscissae, the curve obtained a series of maxima and minima. Alkali metals having the largest atomic volumes occupy the maxima of the curve. For example, lithium, sodium, potassium, rubidium and cesium. These are the alkali metals and which occupy the maxima of the curve. So you can see that in the picture. And next point is alkaline earth metals lie at about the midpoints of the descending portions of the curve. For example, beryllium, magnesium, calcium, strontium and barium. So these elements occupy the midpoint of the descending portions of the curve. The next is the halogens occupy the position on ascending portions of the curve before inert gases. For example, chlorium, bromium and iodine. These are the halogens occupies the position on the ascending portion of the curve. And the transition metals occupy the minima of the curve. For example, copper and cobalt. These are transition elements occupy the minimum point of the curve. So now we'll be seeing what is Mendeleev's periodic table. So after studying the properties of every element, Mendeleev found that the properties of elements were related to atomic mass in a periodic way. The elements were arranged in the periodic table at that time in the increasing order of their atomic masses. Some gaps were left for the elements yet to be discovered. Thus, if a certain new element is discovered, it can be placed in a new group without disturbing any existing group. The total number of periods are 7 and the number of groups are 9 in Mendeleev's periodic table. Next point is, however, a demerit of this table was that there was no fixed location for hydrogen. So what was the demerit of Mendeleev's periodic table? There was no fixed location for hydrogen. Also, the increasing atomic mass was not regular while moving from one element to another. For example, cobalt and nickel. Cobalt had an atomic mass of 58.93, whereas nickel had an atomic mass of 58.71. However, in this table, cobalt was placed before nickel. So actually the atomic mass of cobalt was greater than the atomic mass of nickel, but it was placed before nickel. So that was the fault of this representation. Now we will be discussing about the modern periodic table in chemistry. So Henry Moseley discovered the modern periodic table. The atomic number of elements were discovered by Henry Moseley. In modern periodic table, Moseley done this arrangement based on the atomic number, so that elements are arranged on the basis of increasing order of atomic number. Elements in the same groups are categorized by same number of electrons in their valence shell. Horizontal rows of elements are called periods and vertical columns are called groups in a periodic table. So the horizontal rows are called periods and vertical columns are called groups in this modern periodic table. So the number of periods in the periodic table was 7 and the number of groups in the periodic table is 18. Now the shortest period, that is first period, containing only 2 elements, that is hydrogen and helium. The total number of elements in the periodic table is 118. So the 1118. So the 1118th element was oganesson. Number of naturally occurring elements in the modern periodic table is 92. The first artificial element in the modern periodic table, as per the modern periodic table, is technetium and its atomic number is 43. So you can see the representation of modern periodic table, that is IUPAC periodic table. So what is IUPAC? It is the International Union of Pure and Applied Chemistry. So this is the periodic table that we follow in chemistry nowadays. So you can see the elements like hydrogen and helium in the first row, the first period, and lithium, beryllium, then bromine, carbon. So you can see boron, carbon. So you can see all these elements. So as we studied, the vertical columns are called group and the horizontal columns are called periods. Okay, so this is a representation of modern periodic table. Now the metals are on the left side of the periodic table while non-metals are placed on the right side of the periodic table. The group 1 elements are called alkali metals. Group 2 elements are called alkaline earth metals. Group 17 elements are called halogens. Group 18 elements are called noble gases. Elements with atomic number 57 to 71 are called lanthanides or rare earth elements. And the elements with atomic number 89 to 103 are called actinides or radioactive rare earth elements. The elements of group 1 and group 2 are known as S-block elements. Elements of group 13 to 18 are called P-block elements, only block which contains metal, non-metals and metalloids. So P-block is the only block which contains metals, non-metals and metalloids. And the next point is elements in group 3 to 12 are called as D-block elements or transition elements. And F-block elements are known as inner transition elements and includes lanthanides, that is 4F series, and actinides, that is 5F series. And the last point is S and P block elements are together called as representative elements. So these are the important points regarding the periodic table. So friends, that's it for today. So if you like this video and you feel that this video is informative, please like it and subscribe our channel. Also please press the bell icon so that you will get the notification of all the new videos that will be uploaded in this channel. I will meet you again with another informative video. Thank you for watching and have a good day.